In this video, we take a look at the Arnold parameters tag. So let's right click on the abstract object from the C4D28 tags, add an Arnold parameters tag. If you go to the tag tab, you have this show custom parameters. If you enable it, you are going to get this Arnold node type list. As I mentioned earlier, Arnold parameters tag is dynamic. So based on the type of object you apply this tag to, you're going to have different options in the Arnold parameters tag. And here you can see different types of parameters tag in case you wanted to define the object type manually. Let's disable show custom parameters. Down here you have user options, which you can use it in different ways, including defining object ID. Export user ID. If enabled, then the given ID is exported as an integer user parameter called user_ID. Then the ID can be read in a shader network via the user data integer shader. Export toon ID labels the shapes which belong together regarding edge detection of the toon shader. The use toon ID option in the toon shader has to be turned on for this export toon ID to work. Under the main tab, we have primary visibility. If you disable it, the object won't be visible for camera rays, but still visible for other ray types like specular, transmission, and diffuse. You can see it right now on the sphere and through the glass. We have shadows. If disabled, the object won't cast any shadows. We have visible in diffuse reflection and diffuse transmission. If diffuse reflection is disabled, the object won't affect global illumination or indirect diffuse rays. If diffuse transmission is disabled, the object won't be visible in the diffuse transmission and subsurface scattering. We have visible in specular reflections. If disabled, the object won't be seen on reflective surfaces. Visible in specular transmission. If disabled, the object won't be seen through transmissive or refractive surfaces. So as I disable it, it can't be seen through the glass. Volume scattering checkbox controls if the object is visible in indirect volume rays or not. We have double-sided, whether the surface is double-sided or not. Invert normals here inverts the surface normals of the geometry. We have self shadows. If disabled, the object won't cast shadows on itself, but still cast it on other objects. You have receive shadows. If disabled, the object won't receive shadows from other objects in the scene. We have opaque, which determines whether the object is opaque or not. In previous versions of Arnold, when we had a transmission shader or a shader with opacity, you had to make sure to disable the opaque option for the object that had that shader in order for the shadows to look correct. But right now Arnold does that automatically and you don't need to manually define whether the object is opaque or not. We have matte. If enabled, turns the object into a holdout matte. It only affects primary rays, so you can still see it in reflective surfaces or through refractive surfaces. But if I change my IPR display to alpha, you can see it is also black in the alpha channel. We have trace sets, which we discussed it in the shading section of the course. We have SSS set name here. I have these two spheres with subsurface scattering shader applied to them, and they are interpenetrating each other or overlapping each other, and you can simply differentiate them because of this dark boundary between them. If I want Arnold to consider these two spheres as belonging to the same SSS set and therefore blurring across object boundaries, I need to make sure these two spheres have the same SSS set name. So let's right click on the first sphere and apply an Arnold parameters tag. For the SSS set name, type something like A or whatever you want. And now let's duplicate this tag on our second sphere. And now they have the same SSS set name. As you can see, they look to be one whole object. At the time being, we are using the diffusion algorithm to handle the SSS shader. If we use any of the random walk methods, we don't need to use the SSS set name, as the overlapping objects will look correct and belonging to the same entity when using random walk methods. But if you use the diffusion mode, you can utilize SSS set name. Now let's get back to the Arnold parameters tag that we have it applied to the abstract object. We discussed subdivision and displacement tabs in the lessons when we were discussing displacement mapping. Let's go to the export tab, and here you can define which vertex maps of the object to be exported and can be therefore used later on in shading networks. Let me quickly select the object itself and go to the polygon mode and select bunch of polygons here. And from the select menu, choose set vertex weight and set it to 100% and press OK. Now we have a vertex map tag added to our object. Let's go to the model mode again and select the Arnold parameters tag. Now you have export vertex maps and it is set to all. So all the vertex maps of this object will be exported by default. You can change it to selected and add your desired tags here to the vertex map list. If set to none, no vertex map will be exported for this object. I'm going to set it to all again. Record reference object allows you to use a reference state, a PRF or reference positions or bind pose of the object for shading purposes. For example, to avoid swimming of procedural textures when the mesh is distorted. With PRF coordinates, you can always reference the same point on an object even when the object is deformed. Click on the record reference object button to store the current state, points and normals of the object. You need to enable them down here. When generate UVs is enabled, the UVs of the object are overridden by the UVs generated from a specified texture tag, and in this texture tag field you can define the texture tag to generate the UVs from when generate UVs is enabled. Let's move over to the motion blur tab. The first option is enabled, and if you uncheck it, this object is not gonna have any motion blur even if you have global motion blur turned on. You have use motion vector. If enabled, motion blur for this object will be calculated using a velocity vector, and down here you can define the vertex maps to derive motion blur. If you check out Arnold support page, they have a great example on how to use motion vector practically, and I think covering this would be beyond the scope of this introductory course. So that was a quick look at Arnold parameters tag. See you in the next video.